Okay, number 3, you're given a tan squared x minus tan x is equal to 0, and they're asking us to solve for x on the interval 0 to 2 pi. That's my domain restriction. So it's a quadratic, so I need to factor out a tan x. That will leave me with a tan x from this, and then minus 1 from my second term. I'm going to set each factor equal to 0, so I get tan x equals 0, and I get tan x minus 1 is equal to 0. This is tan x is equal to positive 1. Okay, now I have to solve for x. So I have to find out where is tan x is equal to 0. Well, if you remember, this is sine x and cosine x is equal to 0. So the only way a fraction can ever equal to 0 is if the top of the fraction is 0. So we've got to find out on the unit circle where is sine x 0. There's 0 here, so x is equal to 0. Is 0 there, and that's when it's pi. And you come all the way around back to there, which is 2 pi, because we have brackets on 2 pi. So that's one set of solutions that I have. Now we got to figure out where is tangent of x is equal to positive 1. Well, only way tangent of x is equal to positive 1 is because when both the sine and the cosine are exactly the same. So they're exactly the same here, okay, and that happens to be pi over 4. So x is equal to pi over 4. And sine and cosine are exactly the same there, and which is 5 pi over 4. And that's it, because we don't have, we're only going around the circle once. Okay? These are easier problems than what we did in the past. Okay, this is section 11, or xi, and we're graphing. So let's start with number 4. Y is equal to negative sine of 2 pi x over 3. Okay, so we know it's a sine curve, but negative means it's going to flip the sine curve. We just have to figure out what the amplitude is. So amplitude is still 1. Okay, and we have to figure out what the frequency is. Frequency is 2 pi over 3. So that tells me what my period is. My period is 2 pi divided by 2 pi over 3. So this is the same thing as 2 pi multiplied by 3 over 2 pi. So they cancel out. My period is 3. Okay. Alright. So do I have any vertical shift? I don't have anything attached at the end right there. Okay. So no. There's nothing attached at the end. So none. Do I have any horizontal shift? Okay. Or phase shift? I don't have anything attached to the x. So that's none. Alright, let's sketch the graph of this. It's easy. Amplitude first. So I'm going up 1, down 1, negative 1. This is my y-axis. This is my x-axis. I'm going up to 3 because that's my period. And halfway between that is 3 over 2. And halfway between that is 3 over 4. Okay. And halfway between this is going to be 3/4, 3 over 4 plus 3 over 2. So a quick way to add is multiply there, which is 6, multiply there, which is 12, and multiply the bottoms, which is 8. Okay, so that's going to give me 18 over 8, or if you want to reduce that, that reduces to 9 over 4. So this is 9/4. Alright, normal sine curve starts here, so does this one, but normally we would go up, but since there's a negative in the front, it will go down. Okay, so we'll go here, and then it'll be back in the middle again, and then back to the top, and then back to the middle. So this sine curve, for one full period, it will look like this. That's it. Alright, let's do a harder one. Number 12. And this let's go section number 11. Alright, number 12, you're given y is equal to 2 minus 3 sine of 2x minus pi over 2. Okay, so I like to write the 2 in the back, so I'm going to rewrite this. Okay, it'd be negative 3. You don't have to. Okay, and I also like to factor out, okay, and get my b right here. So that means I need to factor out a 2 from here because I need to have an x. So when I pull out a 2, I get an x left here. But when I factor out a 2, I need to put pi over 4 there. So when you think about it, when you multiply these two things, it will get you that. Okay? So, and then I have a plus 2 at the end. Now it's easier to see what all the information I need. So my amplitude is 3, and my frequency is 2. So my period is going to be 2 pi divided by 2, or pi. And I have a horizontal shift of pi over 4 to the right, pi force to the right, because it's negative. And then I have vertical shift, okay, 2 units up. Alright, let's go ahead and you know what? I am going to, I know I have a horizontal shift, so I'm going to draw a temporary y-axis. So there's my x-axis, and I'm going to draw a temporary y-axis because I know I'm going to erase that. Okay, so the y-axis. Now I have a vertical shift of 2 units, so that's my 0. I'm going to go over here, call that 2, and that's going to be my new middle. So I'm going from 0, or I'm going from 2 up to 3. So if I go up to 3, that's going to put me at 5. That's my high point. I'm going 3 down. That's going to put me at negative 1, and that's my low point. My period is pi, so I'm going to go over here, call that pi, start cutting everything into half, pi over 2, and this is going to be pi over 4, and this is going to be 3 pi over 4. Okay, so this is a sine curve. That means it starts right there in the middle. And this is a negative sine curve, so it means it's going to go down. So that means it's going to hit the bottom here. And then the next step is going to hit the middle again. And then the next point is going to hit the high point. And then it's back to the middle right there. So my curve looks like this. Okay, the only thing I haven't done yet is the horizontal shift. And you know what I'm going to do with that? I'm going to shift my y-axis to do it. So I have to shift my curve pi force units to the right, or shift my axis, okay, pi force to the left. So I'm going to shift my axis here, and that's going to be my new 0. Okay, so I'm going to transfer all my information. That's 2, that's 5, and that's negative 1, and that's my new 0. Then I can erase my old y-axis, so it's not so confusing. Okay. Alright, but I have to change the other x values too, so I have to add pi force to everything. So when I add pi force to 0, this is no longer 0, that will be pi over 4. Okay. And then when I add pi force to pi force, this is going to be pi over 2. And when I add pi force to pi halves, it will be 3 pi over 4. And when I add pi force to 3 pi fourths, it'll just be a pi. And then finally, when I add pi force to pi, I'm going to get 5 pi over 4. And it's done. Alright, so let's move on to the next section, section 12. Okay, and let's do number 2 as an example. Refresh your memory. F of x is equal to 10x to the third plus 21x to the second minus x minus 6. And we're asked to find all the zeros. Okay, that means they want me to set that equal to 0 and solve for x. Those are all the zeros. Now, first of all, I need to factor. But notice I can't cut it in half and factor any of this stuff, so that means I have to go p over q's. So my p's are factors of -6 will be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And my q's are factors of 10. Okay, so that's going to give me plus or minus 1, plus or minus 2, plus or minus 5, and then plus or minus 10. Okay, so therefore my p over q, that means I got to put each one of these q's underneath that. P, so plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and then plus or minus 1 over 2. But 2 over 2 is 1, so that's right there. Then plus or minus 3 over 2, and then I have 6 under the 2. The 2 under the 6 is going to be plus or minus 3, and I already have that. Then I'm going to use 5, so it's going to be plus or minus 1/5, and then plus or minus 2/5. Okay, then when I put the 5 underneath the 3, I'm going to get plus or minus 3/5, and then when I put it underneath the 6, I'm going to get plus or minus 6/5. Okay, and then last thing is I got to put 10 underneath each one of that, so plus or minus 1/10, and then plus or minus 2 over 10, which is the same thing as 1/5, so I already have that, plus or minus 3 over 10, and then finally plus or minus 6 over 10, and that reduces to 3 over 5, and I already have that. Okay, so my options are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have a total of 24 choices to start. But this is a cubic, so if I find one, it's going to become a quadratic, so I can solve the others. Okay, what do I want to try? I have to use synthetic division. Okay, so I have a 10, 21, minus 1, and minus 6. And I'm trying to get a 0 at the end. Alright, well, you know what? I got some minuses inside here, so let's try just 1. So I get 10, multiply, I get 10. Okay. And to multiply by 1, it's 2. It doesn't work. Okay, so 1 doesn't work, so let's keep it simple and let's go to -1. Maybe that will help out. Okay, so -1. Add, then multiply, get -10. And add, I'm going to get 11. Okay, multiply by a negative, I'm going to get negative, I'm going to get -11. And that becomes -12. No, that's not working. Okay, so maybe I should go to 1/2, and I have that because 2, -2. Yeah, I think it might. Let's try 2. Yeah, have a hunch. Okay, so or -2. Let's try that. So 10, multiply that, -20, and it's getting smaller now. I'm going to get 1, multiply that, -2, okay, and then add that, I'm going to get -3, multiply that, I get 6. Okay, that worked. So we're in good shape. Okay, so one of my zeros is x is equal to -2. So what I have left is this right there, which is 10x squared, okay, plus x minus 3 is equal to 0. And if I can factor, I can factor that. If I can't factor, I can always complete the square or use a quadratic formula. So let's see if we can factor that and cross our fingers. Okay. So how do I want to split the 10? I can either go 10 and 1, 5 and 2. So we're getting smaller here, so let's just go 5 and 2. So 5x and 2x. But there's only one way to split that one, and that is to 3 and 1. So if I put 3 here, 1 there, I can get 6 and 5, and you make that plus, make that minus, and that's factored. It works out for us. So I'm going to set this equal to 0. I'm going to get x is equal to -3 over 5. And when I set that equal to 0, I get x is equal to 1 over 2. So 1/2 would have worked also, and -3/5. Okay, so but we did go to 2, so we have our 3 solutions because this is a cubic. We'll get 3 solutions. Alright, one more problem, and then we are done for the notes. So let's go to the last section, in section number 13. Okay, X, I. Alright, let's go to number 4. Number 4, you give an f of x is equal to x to the third over x to the second minus 1. Okay, it asks you to find, it wants you to graph everything and state the x and y intercepts, asymptotes, and the domain. Okay, what I want is, I don't want you to graph it. I want x and y intercepts. I want vertical asymptotes. Okay, horizontal asymptotes, we'll cover that in calculus. And the domain, I think you can set the domain right now. Alright, so first of all, let's get the domain. Okay, there's a restriction here. X cannot be 1 or negative 1, because that will give me 0 on the bottom. So, okay, so domain is set of x's such that x is an element of reals, and x cannot equal to plus or minus 1. Okay. Alright, so that's the domain. But you know what? But that's also, those are also my vertical asymptotes. So I have vertical asymptotes at x is equal to 1, and I have to write them separately, and x is equal to negative 1, because that's what makes the bottom undefined. The only thing that's left now is to find the x and the y intercept. X-intercept means I got to turn my y into 0. So this is my y. So 0 is equal to x to the third over x squared minus 1. The only way this fraction can ever equal to 0 at the top is 0. So that means when x is 0, I have x-intercept. So x is 0 is my x-intercept. Okay, what about the y-intercept? Y-intercept means I'm going to turn all the x's into zeros. Okay, so when I do that, I'm going to get 0 over 0 squared minus 1, which is 0. So that is my y-intercept. Y is equal to 0. Okay, so because that's my y. Alright, so x-intercepts, y-intercept. Alright, let's do one more and then we're done. Let's go to number 6. In number 6, you're given a fraction f of x is equal to x to the second plus 4x plus 4, all that over x to the second minus 4. You can't really talk about the domain and the vertical asymptotes unless you put this in a factor form. So let's see if we can factor the top. We're looking for factors of 4 that I can make a 4 out of. That's going to be x plus 2 times x plus 2. All that over. The bottom is difference of 2 squares, so that factors will be x plus 2 times x minus 2. They cancel, which is going to give you x plus 2 over x minus 2. Alright, now when things cancel out, these are known as removable discontinuities, so domain can't exist there either. So I have a restriction, x cannot equal to negative 2. Well, x also cannot equal to positive 2 because I will turn that into 0. So positive 2. So this is my domain right there. So I'm going to write that out. Domain is equal to set of x's such that x is an element of all reals, and x is not equal to plus or minus 2. Alright. Now, do I have vertical asymptote? Yes, I do. So since this didn't go away right there, okay, that creates a vertical asymptote. So my vertical asymptote is when x is equal to 2. That is my only vertical asymptote. This canceled out, and that actually gives us a removable discontinuity or a hole in the graph. We'll talk about that more next year in calculus. Okay, what else do I need to find? X-intercept and the y-intercept. So let's go find the x-intercept. X-intercept means I'm going to turn my y into 0. So 0 is equal to x plus 2 over x minus 2. Well, when is this fraction ever equal to 0? Only when the top is 0. So that means x has to be negative 2. Okay, so that's my x-intercept. What about my y-intercept? My y-intercept means I'm going to turn all the x's into 0. So y is equal to 0 plus 2, all that over 0 minus 2, which is 2 over negative 2, which is negative 1. So y is equal to -1 is my y-intercept. That's where it crosses the y-axis. Alright, that's it.